And we're going to have a quiz on Wednesday.
On what?
Just not even the fraction stuff, up to the fraction stuff. So the fraction stuff will not be on your quiz. So the pages for your quiz will be from page 1, the number families will be on there, up until the end of page 9. Okay. Yeah, let me just see. Yeah, I have. I can give you a pencil.
Yes, Jim. One. Throw it.
You can catch it. You can. All right. So, quiz on Wednesday. Up to page 9 in our notes. So that's like all your number families. Can you tell me if a number belongs to natural numbers, whole numbers? That's something you definitely need to study, because that's not something you're like, oh, I'll just figure out the math. No, it's like definitions. Changing from mixed radicals to entire radicals and entire radicals to mixed radicals. But none of the fractional exponents are going to be on there. That's going to be on your next quiz. So, converting to exponential form. Exponential form is when you write everything with exponents as fractions. You have two options here. Option 1 and option 2. Option 1 is right away you change the cube root. And what do I change the cube root as an exponent to? 1/3. That's option 1. Option 2, you simplify first. Option 2 says, can I simplify the 2? No. But I can simplify the b cubed. If I had 3 b's inside of a cube root, I can bring how many out?
2.
Not 2 of them. No. Not 3 of them. How many b's? If I brought the b's out in front and changed it to a mixed radical, I could bring out 1 b, because a cube root, you need 3 of them to pull 1 out. And then I could change to a fractional exponent. Now these look a little bit different. Question? No? That's just hand up in the air. Eyes in the air. Okay. All right. Just sometimes he likes to stretch with his hand up like that. That's perfect. Okay. So this one, we need to know our exponent laws from grade 9. We need to know our exponent laws so well that when we deal with weird situations like fractions, we remember what they are. 2b cubed to the 1/3. This is the exponent law in grade 9 that says everything goes to this exponent because you're multiplying. This doesn't work if you're adding, but if you're multiplying, this means you'll have 1/3 for the 2, because it's 2 to the 1. So you multiply the 1 times 1/3, you get 1/3. And you multiply the exponent here, the 3 times the 1/3, which would give you 3/3. Which is just b. And can you see that they're the same? So if you had to change this one to exponential form, you'd have to decide what's easier for you. Doing the 1/3 first and then working with your exponent laws to simplify, or simplifying radicals first and then working with your exponent laws.
What was the one before that evaluate
4 to the 3/2. We had done that one earlier, but we can do it again. You can think of it like this by breaking it up. And 4 to the 1/2 is the same as a square root. That's pretty easy. Square root of 4 is 2. and then 2 cubed is 8.
Thanks.
So this one will be similar to that one, but now we have a decimal.
1 over 4.
Careful, it's 2.5, not 0.25. You're right, though.
Oh.
Very good idea. Do you see what he's saying? Change it to a fraction. Because we have a way to change fractions to radicals and radicals to fractions. So if you have a decimal, and this is going to happen more and more as you go further and further in math. Further and further in math, fractions are much easier to work with and more helpful than decimals. And then I would probably, right, you can choose whether you want to do the power of 5 first or the half first. Mental math-wise, doing the half first is easy. 9 to the 1/2 is the same as square root of 9, which is 3. Woo, and there's some mental math for you. What is 3 times 3 times 3 times 3 times 3? That's a big number. Unless you think 244 is small, because then this is even smaller. 243.
Would we be allowed our calculator?
Yes, you'd be allowed your calculator. However, I would ask you to show your work for simplifying. So this 3 to the 5, I will let you use your calculator for, but I wouldn't be like, oh, this is not okay, just to take the whole thing into your calculator and get the answer. Because then you haven't shown any of your work. So usually a question like this would say, evaluate as much as you can, show your work for how to calculate this. Or, you know what would be a really good multiple choice question would be to say something like this. You wouldn't need a calculator for this. There we go. A, B, C, D. That would be a good multiple choice question because you'd have to know how to change it in order to make that match. Without a calculator one. So one of the skills that you learned in grade 9 was changing fractions to decimals and decimals to fractions. So we have to change 0.4 to a fraction. 4/10. But it's really easy to change something because that's your 10th spot, then your 100th spot. 4/10 is perfect, but then you're right, it's going to make sense to reduce that fraction to 2/5. But 4/10 is a perfect starting point because it's really easy to see that one decimal place is your tenths. You can write it as 4/10. And then you have an option. You can either square first or do the 5th root first. Usually it makes sense to do the 5th root. What times what times what times what times what? The same number times by itself 5 times is 32. 2. It's going to be 2. You know, there's on a non-calculator with a power of 5, there's not very many options I can give you. There's very little options I can give you. Because as soon as you go to numbers, even like 3 was 243. That was, I said, too big already. So 4 will be even bigger. 4 to the 5. Whew. Too big. So, chances are this is going to be easy to figure out, and it is. It's 2. Then you get 2 squared. Our final answer is 4. Okay, I have got a worksheet for you that really practices our fraction rules and simplify. Okay? And they're like, these ones are like level 1 and 2. They're like level 3 and 4. They're a little bit hard. So I'm going to do the first one. I'm going to hand it out to you. I'm going to do the first one with you together. Ten questions. So let's do the first one together. And how is that looking for complexity? Does that look a little complex? Yeah, we're going to simplify these. In fact, that's what we're going to do first. If we can simplify these with our radicals, because that's going to be on your quiz on Wednesday, can you simplify radicals? We're going to do that first. So if I have a square root, I'm going to check the number. Can I simplify the square root of 16? Yeah. Can I bring a number out in front? That would be a 4. Can I simplify an m squared? That would be a number out in front. It would just be an m. But I can't simplify the y, so it would stay the square root of y. The cube root one. Can I simplify the cube root of 27? Yeah. That would be 3. Can I bring out any variables? Do I have enough m's to bring 1, 2, or 3, or 4, or 5, or 6? Can I bring some of them out? Yeah. How many? I can only bring out 1. Because how many m's do you need to bring out 1? With a cube root, you would need 3 of them. So I can bring out 1 m, and then inside would still be left another m. Because there was 4, 3 of them can bring 1 out, still left with 1 inside. And you see that you would still have a y inside. So currently, before I change things to fractional exponents, now I have a 4, an m, a square root, a 3, an m, a cube root. Can you see that you can put the 4 times 3 together? Yeah. That would give you 12. Can you see that you could put the m and the m together? That would give you m squared. And can you see, you can't do the square root and cube roots are different. You can't put them together. So if this question had said, just write it as mixed radicals, we would be done. But the question says, we want to use fractional exponents to express the answer. So that means we want to change the square root of y as y to the
1/3. Oh no, 1/2.
1/2. And the m times y to the 1/3. Oh, this gets practice like so many things you have to practice. Practices your simplifying radicals. Practices your fractional exponents. Practices all your exponent rules. It's going to practice your adding and subtracting and multiplying fractions. We're going to practice a lot in these questions. And you see that your exponent law says if you have 2 things multiplying inside brackets to an exponent, That 1/3 would multiply by the exponents of each of those. And we're not done yet, because you now have a grade 9 exponent law come into question. The grade 9 exponent law says, what do you do if your bases are the same and you have different exponents? What do you do?
Multiply.
Yeah, 3 times 5 is 8.
You
Add them. Oh, okay, good.
I still have 4.
If your bases are the same, and this, like, when you see this, this makes total sense. When you see this, it's not, right? You need to know your laws well to be able to work with the fractions. And same thing here. These ones have the bases the same. So now I can write 12m. How do I add 2 plus 1/3? But we're going to want to write it as an improper fraction. How do we add fractions? You need a common denominator. So I'm going to change the 2 to 6/3 plus 1/3. And for the y, I'm going to have to add 1/2 plus 1/3. What would my common denominator be there?
6.
3/6 plus 2/6. And in the end, our final answer is 12. M to the 7/3, y to the 5/6. If you flip over your page, the answer is there. Okay? And we're only doing questions 1 to 10. It's going to practice a lot of your fraction rules and exponent rules. You can work with a partner or you can work alone. And you can call me over when you get stuck.